Now A plus the absolute of B squared. And this quantity is positive. The quantity absolute of A plus absolute of B is positive. And what's the answer? It's just the absolute of A plus the absolute of B. You see now? Okay. So that's the argument.
Taking a lot of information in one day.
All right. So one more last property before we do maybe some exercise, some application. Okay. One last property, and then we do some one exercise. Okay, so you know the absolute values, as we have seen, it will also help us to solve some equation or some inequation. So whenever you are in a situation where you have some equation or inequation and you need to solve x, you can use this property that I'm about to give now. Okay. So the property number one, let C be any parameter. C is any real numbers. Okay? So whenever I have the absolute of x is equal to C, if and only if s is equal to C or s is equal to minus C. Okay? So if you have absolute of s is equal to C, if and only if s is equal to C or s is equal to minus C, this just comes from the definition. We know by definition the absolute of x is equal to x if x is positive minus f if x is negative. So that's just code. Okay? An example. If I ask you to solve the absolute of x is equal to 8, for instance. We want to solve x. What is the solution? What is the value of x? Such that we have this kind of equation. Okay? So you can use this property. From this property, we know that the absolute of x plus 7 equal to 8, if and only if math notation, we can also write the double bidirection arrow. If and only if, see now, this was a single x. So this single x is x plus 7. Okay? So if and only if x plus 7 is equal to 8 or x plus 7 is equal to minus 8. You understand why? Huh? You understand why? What I wrote? I just applied the property. I applied the property here. So look, this is the property.
So the property knows as an log.
This is what you need to know. Huh? That whenever I have an equation absolute of x is equal to a constant, any type of constants, and of course the constants has to be positive, otherwise it will not be valid. So that simply means that the value of x is C or minus C. Simple. Okay? Now, if you want to solve this, okay, maybe it's because I'm writing SS that is confusion there. Maybe I write A. Okay, let me write A. Let me just change the variable. Okay? So I want to solve absolute of A plus 7 equal to 8. So this one is similar to this equation. It's the same thing. They are equivalent. It's the same thing. It's just that this x here is A plus 7. Okay? Are you following? question. So since a plus 7 is equal to x, then I can just apply this property. So therefore I have, by this property, I have two disjunction. A plus 7 is equal to a, it's or, it's not n, but it is or. She's sleeping, I told you. Okay. The second statement is a plus 7 is equal to minus 8. Okay? So I can solve the both. Okay, so then we have a plus 7 is equal to 8 or a plus 7 is equal to minus 8. Do you know the reason why? Yeah? Do you know the reason why? Just an application of the property. Okay? Who did not understand this one? You don't understand? Okay. You absorb this property? This property? You absorb it? This one is clear, right? Okay, now, I'm asking you now to solve this equation. This is an equation, okay, that I want you to solve, okay? So here, in our case now, x here is a plus 7, and c is 8. Where x is a plus 7, and c is 8. So you just need to plug. You plug, yeah, that's all. So, and then you get this one, and you want 8. 8 is now 1 or what? A is equal to, now you see now 8 has 2 values. But note that this is or, is not end. You see in the chapter 2 that in maths, whenever you see or, end, they are not the same. Okay, they are not the same. Okay? Now another property. So, yeah. Let me take another example. If I have, which example I'm going to take now, which should be very easy, yeah? Okay, maybe absolute of s squared plus 1 is equal to 5. And I ask you to solve this equation. The absolute of s squared plus 1 is equal to 5. How to solve this one? You just need to apply this. Okay, let me write A so that it's not confusing. Okay? So from this one now, you have that a squared plus 1 is equal to 5, or a squared plus 1 is equal to 5, I minus 5. Okay? Yes or no? So this equivalent to a squared is equal to 4, or a squared is equal to minus 6. And a squared is equal to 4, it means that a is equal to 2. N is equal to plus minus 2, or this is not possible as a real number, but it has a solution in complex number. In C, but we are dealing
with number.
Real numbers. So there's no solution here. So
no solution that side.
2 and minus 2. Okay. Another. Maybe you can try this at home. X. Okay. Maybe a plus maybe 12a plus 5 is equal to 3a plus 1, for instance. So now you see, I want to solve the equality of two absolute values. Okay? So just the same thing. What you need to do, you just apply this property, and that's all. So if you apply this property, you set C as equal to this number. Okay? So then you have 12a plus 5 is equal to absolute value of 3a plus 1, or 12a plus 5 is equal to absolute of minus absolute of 3a plus 1. And then inside that you still have another absolute value. You have to substitute again. So then you have a substitution, two substitutions to do. Okay, it's just a homework, you can try it at home. Now let's look at another property. Because you still have 10 minutes or 15 minutes. You can try that one at home. Okay. All right. So another property. So you see that what the property one that we gave here is for solving an equation, not an equation, an equation. What about an inequation? So whatever I have C as real numbers, the absolute value of x is strictly less than C if and only if minus C is less equal no, strictly less than x, strictly less than C. Okay, that's the point. Okay? We can try to see why it is true, but for the sake of time, we just skip it. Okay? So you can always apply this whenever you have some inequation to solve. And let me give an example. If I want to evaluate the absolute value of example, I want to solve x plus 5 less than 3. I want to know what are the real numbers such that this inequality are satisfied. Or this inequality is satisfied. Okay? What are the real numbers x such that you have this? Okay? So we just need to apply this property. And from this property, we know that x, the absolute value of s plus 5 less than 3, if and only if we have this inequality. Our C here is 3. Huh? What's happening? You not follow? Is it boring? Huh?
It's
Are you
complicated.
following? Huh? Okay. Are you understanding? That's why I'm asking when you want to start, I say, do you all have a math background? So you say yes, okay. Yeah. The first one? The first. This one. Okay. It's not clear. Oh, okay. All right. Okay, so you see this statement is an inequality here. Do you know how to solve an inequality for that's the first question that I want to ask. If I give you x plus 5 greater than 3 and ask you what are the value of x, can you do that?
Yes.
Huh? So what are the value of x? X is greater than 2. Okay, so x is greater than 2. What? Minus 2. Okay, good. Minus 2. So all real numbers are greater than 2. 3, yeah? That's an inequation. So it's a set of numbers. The first statement, equation, you just want to know what are the exact value. And then you receive maybe 2 numbers. But for the equation, you could see some range of numbers that satisfy a given statement. Okay? So you see that this equation the absolute is not involved. Okay? But now we want to try to see if we want to solve an equation whereby the absolute is involved. For instance, I replace this one by absolute and I want to know, can you give me the numbers? What are the real numbers that satisfy this? Or maybe I will just change it because it's something that I wrote this. You see that I modify the statement in such a way that I involve the new concept that we are seeing now, the absolute value. And in order to solve this, but we did not. So this is not. I didn't give you the property for this one. So if you have the absolute or a given number is strictly less than C, then you can always write this one. You can always bound x by minus C and C. Simple. We can always keep that bound. The upper bound and the lower bound are maximum and minimum. Okay? That's all. And then I give this example. Okay? So in our case now, you don't see x, the x here is just, you can see that x plus 5. So this just implies that minus 3 is strictly less than x plus 5, strictly less than 3. You understand what I just wrote there? At the back. You understand? Okay.
Okay.
So, and then you can solve x. This is minus 8. Minus 2, right? So what are the value? X is between minus 8 and minus 2. So you can actually draw the line. You have minus 8 here, you have minus 2. So is this interval. This is the solution. The solution of our inequality is this one. Yeah.
I can understand your graph there.
My graph.
Yeah.
The graph that I just drew now.
Yeah.
I just give the representation. The representation of the set of solutions as a line. Okay? We know that if you want to represent any real number, then in a given line where the origin is 0. So any real numbers can be represented on a given line. Okay? So
there's no way one zero between negative 8 no
have the reference 0. 1, 2, 3. Minus 1, minus 2, minus 3, and so on. Okay? So if I ask you, where is the point square root of 2? Square root of 2 is a real number. Square root of 2 is somewhere here. Or I don't know, maybe it's here. 1.41. So you can represent it. Okay? So you see now our line, the origin is here, and then I just represent minus 8 and minus 2. And we know that the x must be greater than minus 8, and it must be less than minus 2. Okay? It must be greater than 8, minus 8, and lesser than 2. That's the interval. For this to satisfy. So this is end. So I can write this statement like this. It is, I can rewrite that, okay, x is greater than minus 8, and x is less than minus 2 is n. And that gives you this graph. This graph. Okay? What's the time now? The class is supposed to end at what time? Quarter past 2. You still have 5 minutes. Okay, so you understand this? You understand this? Okay. So the last property. So if you have the absolute value of x greater than c, if and only if x is less than 1 or c, or s is, so here now is is greater, superior, it's greater, but the other is less. So whenever you are in a situation whereby you have this, know that you should apply this, not the other way around. Very important, because these two statements are not the same. This and this, they are not the same. They are not the same, Okay? So let's give an example and then we solve the example. Then try to solve 2x plus 1. Okay, 2x plus 1 is greater than 0. 0. Minus 0. Minus 0 is 0. Minus 0 is 0, right? So, what will you do in this situation? When you have this, okay, in order for us to see, let's write 1. Let's write 1, so that it will not complicate. So, no. Let me write 3, okay? So if you have this situation, you should not apply the previous inequality. Because if you apply it will not give you the solution. Okay? So by this property now, we have this, we have that our 2x plus 1 is less than what? Minus 3. Or 2x plus 1 is what? Greater than 3. Yes or no? Yeah, okay. So then I just apply the property. I replace x by the value and c by the value, and then I got this one out. And you know how to solve some basic inequation. That's a basic inequation to solve. Okay? So you have now x should be less than this is minus 4 minus 2, or x should be greater than what? 1, right? Or it is or, right? So how, if you want to represent this now, what will you do? You can represent it. Okay? This is a union. It's not an intersection. It's a union. It's either this or this. But what we just saw before is intersection. Both are the common. Okay? Any question? Question? Yes. How? The graph. Yeah. You draw the line and then the value of from it minus 2 it will be the other side like this. You have 0 minus 2. This side. Okay? Less, and then you have 1. This side. It's not both. It's either this or this. The solution is either this or this. So this is how you can represent. Any other question? Question? Yeah. What's the between and n? N. M.
Orange end.
What? And N. Okay. She's asking the difference between or and N. Okay. All right. What's the difference? So whenever you see or, it's good. You will see in the next chapter. But it's a good question. And you see in the next chapter set. You have chapter 2 is logic, and chapter 3 is a set. whereby they will ask you to evaluate the disjunction, the intersection of two sets, or the union of two sets. Okay? Yeah, but I can just give you an example now, right now. So if you have a given set, let A, B be two sets. So you want to know what is A union B. They can ask you to evaluate A union B, and ask you to evaluate A and the intersection with B. Okay? So A intersects with B are the values that are both in A and B at the same time.
Functions.
Both in A
But
and
we're
B at the same time.
functions.
So I give an example. If I take A as minus 7, 2, this is an interval, and I take B as 1 to 5, and I want to evaluate. So this intersection mean N, and this union mean all. Okay? So if I want to evaluate this now, let's try to represent. We have 0, minus 7 is over here. Minus 7 is here. The first interval A is, we have 1, 2. Okay? So that is the first one. That is 8. I'm representing A. This is A. Okay? So A is minus 7. Why are you going out? So it's minus 7 and 2, and the second one is 1. Maybe if I have color, it will be much better. It's 1 and 5. Okay? So this is the second interval. So what is the intersection now? The intersection is this one, this part. You see now?
Oh.
And
Yes.
the intersection of those two intervals is what? Is 1. Is 1 and 2. Okay? So the intersection will give me 1, 2. So N. Okay? So this is just but you see more details in chapter 3 in sets. Okay? Okay, you are free to go now. But if you have any personal question, you can see the information.